Yo, 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 what's going on? What's going on? It's your man, Deshaun Lyons. Welcome to Trade Digital 89. Sorry for the long wait for a video, but I've been sick for a while. I've been sick for a while. I'm getting much better, but I know I gotta drop an episode. I feel like this is very, very important. So today we're gonna be learning how to do Bubblesort algorithms. Everybody hear algorithms all the time. Um, People use algorithms to solve problems. People use algorithms for ad campaigns. You use algorithms for a lot, especially when you in technology. That's all you use. So today we're going to be learning the simple algorithm of bubble sort algorithm. Hold up. So we're gonna be using this very very slow. It's because we're gonna be learning the beginning part of sorting algorithms, sorting out a random list of numbers and sorting them in numerical order. So we'll have random numbers, and we want to sort these numbers out in numerical order. And each sorting algorithm have many strategies. They have a quicker way to sort it out, and have really slower ways to sort it out. So now we're going to go over bubble sort, and bubble sort is the slowest algorithm that used to sort out these random numbers. So I'm going to share my screen. Let me share my screen now. And we're going to first explain. Let me see. Let me go to the PowerPoint that I have here for bubble sort. Let me see. I don't see anything. Hopefully it pops up. Oh, well, my computer just went very, very slow right now. All right, here we go. All right, so what we see here, let me go over here. So what we see here is something called bubble sort. What is bubble sort algorithm? Bubble sort is a sorting algorithm used to sort lists, items, in ascending order by comparing two adjacent values. If the first value is higher than the second value, the first value takes the second value's position, while second value takes the first value position. So if you see this example right here, this is the example of how it sorts out this random list of numbers. So you see the first pass in the first example for the random list of numbers, you have 5, 1, 4, 2, and 8. So you see 5. So it starts with 1. So you'll see 5 is greater than 1. So 5 is going to go in the second position, and 1 is going to go in the first position. Because remember, if the first value is higher than the second value, the first value takes the second value's position. So that's why 1 is going to swap with 5, and 5 is going to be the second position. Now you see the second icon now. So now now 1 is in the proper position, and 5 is, and now we got to go to the next two numbers inside the list. So now we have 5 and 4. Now, is 4 greater than 5? No. So have to swap. So remember, or you could just look at it like this: if 5 is greater than 4, yes, and then it swaps. And I'm just trying to compare. You see where this pointing line is going towards, because usually you'll see when we do the code. That's why I wanted to say it like that. So the first value will be 5 right here, and 5 is greater than 4. So 4 is going to swap with 5, and 5 is going to swap with 4. So you see the third position right here of this random list of numbers. So we have 1, 4, 5. That's sorted. Now, is 5 greater than 2? Yes. So now 2 swaps with 5. So 2 is in the position where 5 is at, and 5 is in the position 2 is currently at. So now we up to the second to last list of numbers. So now we have 1, 4, 2, 5, and 8. Now, is 5 greater than 8? No, so there's no swap. Because remember, if the first value is higher than the second value, the first value takes the second value position. If not, there's no swap. So now this is our list of numbers so far. So it's 1, 4, 2, 5, and 8. So now we into the second example of it. This is the second pass of it. Now, is 1 greater than 4? Remember, the first value is the first value greater than the second value? No, so there's no swap. So now we go to the second example. So now we look at 4. Is the first value greater than the second value? Is 4 greater than 2? Yes. So there's a swap. So 2 swaps with 4 and 4 swaps with 2. So now we have on the third set, we have 1, 2, 4. So now you see the pattern. 4 is not greater than 5, so there's no swap. So it goes to this, the second to last list. 1, 2, 3, 4, 5. 5 is not greater than 8, so now goes to the last one. And now it's everything is in order. So now we got 1, 2, 4, 5, and 8. So that's why the third example we have no swap. Is 1 greater than 2? No swap. Is 2 greater than 4? No swap. Is 4 greater than 5? No swap. Is 5 greater than 8? No swap. And now you have your list of numbers. So it went from 5, 1, 4, 2, 8 to 1, 2, 4, 5, 8. So it sorted out these random lists of numbers. So this is the slower algorithm because it's iterating each number inside these random lists of numbers. It's going one at a time, which is the slowest one. They have faster ones like selection sort, merge sort. They got things like that. Now, what we're gonna do now is let me share. Excuse me. So now what we're gonna do is we're gonna start to code. So let me stop sharing for a second. And we're going to go to the text editor. I'm going to be using Atom. I'm going to be using Atom for the text editor. You can use whatever you want, but I'm going to just use Atom just for now. Did it go through? All right. Hope everyone see my screen. All right. So now let me full screen it here. All right. So we're going to now start our code. We're going to code the Bubblesort algorithm. And this is going to allow us to be able to understand what we're coding, understanding the process of bubble sorting, because I explained it, but now coding it is a whole different ball game. Because when you code it, we gotta make sure we're doing the right thing. All of those things. So that's a different ball game. So we can start to code it now. So the first thing we're going to do is we're going to we don't really need that. I'll do it like this. So the first thing we're going to do is we're going to define Bubblesort right here. We're going to define that. And then inside here, we're going to put array right there. Because we want to be able to create our list. The first thing we have to do, we have to create our list. That's the first thing we have to do. So we're gonna do ARR is going to equal to a random list of numbers. We're gonna do 10. We're gonna do 1. We're gonna do 400. We're going to do 77. We're going to do 33. We're going to do 101. We're going to do 99. So close numbers. We'll do 14. We'll do 23. And we'll do 72. So we'll do that. So now, we created our list, and then we're gonna create a value here. We're gonna do n equals the length of our array. Right there. So it's going to be, n is going to equal to the length of our array. It's going to be the length of the array we have. And then we're going to, once we initiate that, we're going to create a for loop. So we're going to do for I in range of n. So So this represents the list of the length of our array. So it's going to go through the length of these numbers. So we have about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10. So we're going to create our formula. So it's going to be going through the range of 10 numbers. So we're going to do a nesting loop right here. So we're going to do, wait, hold on, I may have to make this ARR. Is it ARR? I make right here for our list. If I make a mistake, I'll go back. But I believe it's all right because we gotta return that array. All right. Computer's dying. 1 second, because my computer is dying. So let me charge it. All right, just getting my charger. All right. So now we're gonna do a nesting loop. So so the next for loop we're going to do, we're just gonna create our formula. So we're gonna put for j in range of n minus I minus 1. Now this is all this is saying right here is it's really the length. So if I put the formula right here, it'll be 10 minus I. So I is gonna be whatever I lands on. So if I lands on 2, it really will be 0. And then it'll be minus 1 because it's going to be going to the second position. So you remember the arrow was pointing to swap with the first value. So it's going to start from here. So 10 is greater than 1. So that's why the minus 1 is going to go back to 10 like that. And it's going to keep doing it like that. So, and then it swaps. And then, if 10 is greater than 400, stays the same. So that's why that minus 1 formula there. So it would be, so it's the length. The length equals 10. I represents what position that number is. So 10 is at position 0. So that'll be the first one, right? It'll be the first position. But minus 1 because it's going to swap. It's going to start. It's going to go to the second position, start at 1, and it's going to keep minus, minus, minus like that. It's confusing, but you'll get it once you see the code. So it'll be 10 minus 0 minus 1. And then that would equal to 9. So this list would get smaller, smaller, smaller until everything is iterated through the list. So the whole list is complete. So that's what that formula does. So look at it like that. So it's confusing, but once you see the process, you'll get it a lot more. So now what we're going to do is we have to be able to create the logic based off of swapping. So we're going to create an if statement. We're going to apply if array j. So array j represents, oh, this is hot. So array j is going to represent the first value. And array j plus 1 is going to represent the second value. So if array j is greater than array j plus 1, we're going to swap it. So it's going to be the second value is going to swap with the first value. So it's going to be j plus 1. Array j plus 1 and array j. So the logic is right here. So remember, what I'm saying here, going back to the code, the length of the array is 10 numbers in here. So for I in range of n is going through the range of this list of numbers, which is 10. So we did a nesting loop. So for j in range of this formula, n represents the length of this list, which is 10 numbers. I represents the position that's iterating, and 1 minus 1 is going to be minus 1 of the list. It's going to be is going to be minus the list. So it's going to keep going forward. So the list going to keep getting smaller and smaller once this formula is complete, because it have to iterate through the list. So remember, I know I said -1, but look at the -1. Just really observe the -1 that is making this list smaller. Because if we do 10, if I do, the first one be 10 minus 0 minus 1, it's going to equal to what? 9. Now I'll do 9 minus, or we'll do 10, because it's still 10 numbers. 10 minus 1 minus 1 is going to keep getting smaller. It's going to be 8. 10 minus 1, 9, minus 1, 8. 10 minus, now it's at 2, minus 1. And then you're going to get 7. 10 minus 2 is 8, minus 1 is 7. So the list is getting smaller and smaller based off this formula. So it's helping going through this list. That's what it's doing. So it can help you understand what we're doing here. It's help iterating through this list. The list is getting smaller and smaller until there's nothing else. Until there's 0, there's nothing else in that list. Now, this is the logic right here. This line right here represents the logic. It represents the logic. Because what we want to do is, in a bubble sort, if the first value is greater than the second value, the second value have to swap with the first value. So one, let me put right here. 1 have to be here, and 1 will have to be in the first position, and 10 have to be in the second position. So J represents the first value. So logic. J represents, I'm going to put rep first value. Rep first value. J plus 1, second value. Because remember, I'm going to just put second value. Because remember, J plus 1 would be the second value right here. It will be, it's plus 1. So it's J, which is the first, plus 1 will be the second. So that's how you look at that. So the logic right here, if array J is greater than, if the first position, the first value is greater than the second value, we want to swap. So now that's why we put the second value will be in the first position, and the first position will be in the second position. That's what we do right there. And then we do vice versa. If the, for example, is 10 greater than 400? No, 10 is not greater than 400. So there's no swap. So we just leave it alone. So we just pretty much copy this right here. Array J and array J plus 1. We leave it alone. So this is where the swap happened. The swap. This is where the swap happens right here. So that's where it happens right there. Right there, that's where the swap happens. So now we're going to return everything. We're going to return our array right there. So make sure it's lined up with the for loop. And then we're going to print Bubblesort. And then we're going to put the name of our list, which is ARR. That's the name of our list. So we put it right there. So far, let's go over it again. So we created a list called ARR. It's a random list of numbers. We created a function. If you looked at my previous videos, you'll understand what a function is, right? So we create a function, and inside one of our arguments is array. That's inside our arguments. So n, we created a variable n equal to the length of this array. And the array is going to be the length of these numbers here. So we create a function for I. I represents its iterating through the length of the list. That's why we put for I in range of n. So it's really, look at n being 10. N is 10 because it's 10 numbers inside this list right here. And I represents its iterating through that length of that list. So I represents, it could be 0, 1, 2, 3, 4. It's in a range of 10. Now we did a nesting loop. So now we did another for loop for j in range of n. So j represents us going to number by number. J represents the first value. We go into numbers by numbers by numbers by numbers. But we have to be able to create a formula based off of that. So for j in range of n minus I minus 1. Now the formula we have for here is going to create, n represents the length. So it's 10 numbers. I represents it's iterating through those through the list of numbers. So it could be 0, 1, 2, 3, 4, 5, 6 until the number ends. And and the minus 1 represents is every time it goes to a different number, the list is going to keep smaller and smaller and smaller until there's no more numbers inside that list. So that's what it represents. So we create a formula based off of that until there's nothing else in the list. So we have to create that for j. J have to be able to go through that list efficiently. Oh, this is hot. So now we up to the if statement. So we have to be able to create the logic. If statements, that's where you create your logic, what you want a certain function or your program, what you want it to do. So we create our if statement. So we put if j, which is this formula right here, if j is greater than array j plus 1, which would be the second value. We want to swap it. So if array j is greater than array j plus 1, we want to swap. So array j plus 1, which is the second value, we want to swap it with the first value. So that's why you'll see right here. So we have 10. Is 10 greater than 1? Yes. So 1 replaces, 1 goes to the first value right here, and 10 goes to the second value. It goes to that position. Equals if right here, now we can look at it. So now 10, we got 10 and 400. So is 10 greater than 400? No. So it's no swap. So let me put right here. So now it's no swap. And why is no swap? Because the first value is not greater than the second value. So there's no swap. So that's why we keep array j, which is the first value. So if this logic is not true, like I said, if this logic is not true right here, it's going to just leave it alone. It's going to be no swap right here. So it's going to be array j, it's going to stay the same, and array j plus 1 is going to stay the same. So the first value and second value is going to stay the same. And then we just return the array, and then we print it out. So let's see our function. Let's make sure we got everything right. Now that's you can see it on my screen. Let me make sure you see it on my screen here. And now this is our output for this code right here. Now you see the output of this code. It was able to sort out our list of numbers in numerical order. You see 1, 10, 14, 23, 33, 72, 77, 99, 101, and 400. So it's able to sort out these lists in numerical order like we did. So we'll end this episode right here. I wanted to show the animation side of how the bubble sorting work animation through a matplotlib bar, but we went kind of overboard with this, so we'll end this now. Let me remove this. I hope everybody enjoyed this episode. Please like and subscribe. Dan's a little lagging back, but like and subscribe and share this with everybody. And yes, it's going to be many other videos. I hope you enjoyed it. And that's it for this episode. My name is Deshaun Lyons. This is Trade Digital 89. And peace out and keep coding and keep learning. That's the only way you're going to be great. Peace out.